Now, at this point, you may be thinking to yourself, well, that's nice. When ultraviolet light hits this plate, it makes the leaves go together, right? But that demonstration on its own doesn't show you the true power of the photoelectric effect. A very common use for this, besides discharging previously charged zinc plates, would be its solar panels. A solar panel works because photons of light from the sun, which have high energy like ultraviolet light as part of their spectrum that we can't see, those photons of light hit specially prepared metal solar panels. Those panels release their electrons as a result of the photoelectric effect so that we can have electricity. And any additional electricity that doesn't get used up by a single home can get fed back into the grid for other people to use. So let's have you figure out what would make the best possible solar panel design. For this part of the homework, you're going to need to click on the Photoelectric Effect Lab link in the Google form. Come here to the physics aviary and let's play around with this. I want you to figure out, by conducting small experiments of your own, which factors impact the number of electrons produced and the kinetic energy of those electrons. So just for the ease of things, let's lower this voltage here. We'll just keep it at 0 so that we don't have to worry about stopping voltage for any reason. And what I would like you to do is conduct 3 mini experiments. I want you to figure out when I change the wavelength up or down, which factors impact the number of electrons that are coming off. If I change the brightness, how does that change the number of electrons coming off? And if I change the metal, so by clicking here, I can change the metal from platinum to sodium to silver to cesium to gold. So take a few minutes, try 3 mini experiments: wavelength versus electrons being emitted, brightness versus electrons being emitted, and metal versus electrons being emitted. Notice that this will be observations only at this point.